Okay, Honors Algebra 1. This is the next section of the notes in the quadratics unit. And today we're going to talk about the last form of quadratics. So just like linear functions, there are three forms of a linear function: standard form, slope-intercept, point-slope. There's three forms for quadratics as well: standard form, factored form, and then finally vertex form. Whoops. All right, so today is 3/19. 2020. All right, this shouldn't take too long. Vertex form is pretty straightforward. Let's start with what the form looks like. Okay, so a quick recap. Standard form was f of x equals ax squared plus bx plus c. Factored form was f of x equals a times x minus p times x minus q. And then now the new form, vertex form. If you can hear my cat going wild in the background. Vertex form is f of x equals a times x minus h squared plus k. Okay. So with two new variable letters, we got an h and a k. But now one thing to notice about all three of these forms: standard form has an a value, factored form has an a value, vertex form has an a value. All three of those a values are going to be the same. Okay, so it doesn't matter what form it is. We could write all these equations in all three forms, and that a value is always going to be the same. Okay. Also, on some of the worksheets and stuff, you'll see I would just abbreviate standard form SF, factored form FF, and then vertex form VF. That's on some of the homeworks. All right, so let's go through vertex form. In vertex form, as you might be able to guess, it tells you the vertex. Okay. So we have this vertex form. Well, what part of it is the vertex? H comma k is going to be the vertex. Now you have to be a little careful here. This is a lot like factored form, where we had p and q as the x-intercepts, but it was always the opposite of what we saw because that minus sign was in there. Okay. It's the same thing in vertex form. Inside the parentheses, that minus sign is built in. So the h value, the x value of the vertex, is always going to be the opposite of what you see. Okay. So if you see a minus h, just h is going to be the value. If you see a plus h, negative h is going to be the value. And then k is on the outside. K doesn't have that negative sign, so just whatever you see for k, that's going to be the value. Okay. So hk is the vertex. All right, well, what else can we know? Okay. If hk is the vertex, that means x equals h is going to be the axis of symmetry. AOS, axis of symmetry. And then finally, the k value is either going to be the min or the max. Okay. Because the y value of the vertex is always either the highest point or the lowest point. Now, the vertex form really only tells you vertex stuff. Doesn't tell you much other information. You could find the y-intercept by plugging in 0 for x. Okay. But it doesn't make it a whole lot easier. So kind of off to the side, we'll say. Okay. The y-intercept would be a times negative h squared plus k. Okay. Now that's not, I wouldn't really memorize that or anything, but that's what the y-intercept would be. Now again, we're just normally going to plug in 0 for x and then solve. That's what it is. All right, let's do an example. Let's say our function is, let's do f of x equals 1/2 x plus 3 squared minus 2. Okay. Now again, remember our form. Our form is a times x minus h squared plus k. So with that said, what are our a values, our h value, and our k value? A is 1/2. Okay. H isn't 3, it's negative 3. And then k, again, the h is always the opposite of what you see. And then the k value is just whatever you see, so negative 2. All right, so where's the vertex? Where's the vertex? The vertex is h comma k. H is negative 3, k is negative 2, so our vertex is negative 3, negative 2. Okay, what's the axis of symmetry? Axis of symmetry is the x value of the vertex, or it's the h value in vertex form, so it's x equals negative 3. All right, so let's graph what we know here. Okay, we're going to be working in the negative quadrants. Okay. We know our vertex, negative 3, negative 2. We know our axis of symmetry is at negative x equals negative 3. Now, vertex form is where knowing those typical graph shapes are important. Okay? Because vertex form doesn't tell you a lot of information. It only gives you the vertex, and that's only one point, and it's the only point that doesn't reflect. So we really only know one point. But remember from yesterday, or from whenever the last unit was, if you have an a value of 1/2, okay, they always follow the same patterns. Okay? From the vertex, you could go over and up 1/2. Or more commonly, you could go over 2 and up 2. Okay. You could reflect that over. Okay. The other one was you could go over 4 and up 8. So 1, 2, 3. Should be up here. And then reflect that 4 over to the other side. Okay. So again, knowing those forms is great. Factored form, standard form, it's easier to get points from those. But it's less easy to get it from vertex form. Oh, that's not very good, but whatever. Okay. Now, one thing to take away from this is we just found the x-intercepts. It just happened to land on the x-intercepts nicely. Now, if you're in vertex form, or if you have a graph, and say we want to convert this to factored form. If you know the x-intercepts and you know the a value, you could write anything in factored form. Remember, factored form is y, or f of x, equals a times x minus p and x minus q, where p and q are the x-intercepts, and we know the x-intercepts. We just found them, by chance, really. The x-intercepts from the graph are -1 and 1, 2, 3, -5. Okay. That's your P and that's your Q. So we could plug those in. So factored form is just going to be y equals a. Well, how do we know a? It's the same a that we had in the original problem, 1/2. So factored form is going to be 1/2 x minus p, x minus -1 is +1, and x minus q, x minus -5, +5. All right, now we're going to get into that more in the next kind of main section of these, converting between the forms, but that's just one thing to kind of point out. All right, let's do another vertex form example, and then we'll be done. All right, so in this one, say we have f of x equals 3 times x minus 5 squared plus 12. And we're going to find, let's find everything. We won't graph this one, but we'll find everything. Find the vertex. Find the axis of symmetry. We'll find the opening. Find the domain, the range, and then min or max at what value? So if you want to pause and try this on your own, go for it. Otherwise, we'll go through this. All right, so what do we know? We know A is 3. We know H is +5. And we know K is 12. So we know our vertex, H comma K, 5 comma 12. We also know the axis of symmetry. It's going to be x equals h, x equals 5. We know the opening. The opening is, it opens up. Why does it open up? Because a is positive. A is bigger than 0. Domain, unless it's a word problem, it's always going to be all real numbers. And the range depends on the opening and it depends on the vertex. This one opens up. Any parabola that opens up is going to have a minimum. And that minimum is going to be at the y value of the vertex. Okay. So if you kind of think about this again, we're not going to graph it, but our vertex is above the x-axis. Okay. Our minimum value is at 12 and it opens up. So that means this doesn't actually have, it's not going to have any x-intercepts. All right, and then let's get to the range. The range is going to be, well, it's a minimum, so that means all values are going to be bigger than, greater than, or equal to the y value of the vertex, 12. Now let's find the y-intercept. The y-intercept is always when x is 0. Now again, if you think about our graph, again, I'll just do a quick sketch real quick. I'm not even going to count this out. But 512 is going to be somewhere like way up here. Okay. And this parabola is going to open up. Okay. So our y-intercept, we're pretty far from the y-axis right now. Our y-intercept is probably going to be fairly big. All right, but we'll plug in 0 for x. 3 times 0 minus 5 squared plus 12. It's going to be 5 squared, 25, 75, 87. Yeah, so that's big. So we get a y-intercept of 87. 0, comma 87. Good luck graphing that. All right, but that's vertex form. Pretty straightforward. Again, doesn't tell you a whole lot. It only tells you the vertex. Gives you the a value, so a lot of you can figure out the graphs from there. That's the final quadratic form. Our next section is going to be converting between these three forms using a variety of techniques. All right, homework's going to be in the Google Classrooms. That's it. Have a great day.